guys, welcome to All Electronics. Today a quick follow-up, the part 3 of our series on development of the GPSDO, and I have good news here. We have the oscillator working properly and it works very nice. You're gonna see now here with the equipment on the bench, and we're gonna see the frequency adjustment of the VCO. And now I'm working on the oven that will heat the oscillator, and I think the oven we're gonna test in the next video, but today we gonna see it working, controlling the heat by a power supply on the bench. I still do not have the closed loop control of the temperature, but I think it's gonna be very nice. Let's go. So guys, this is the oscillator mounted here on this PCB. This PCB will be inside a closure here that I think I will make with PCBs also, and a little box soldered with PCBs. And this board that's gonna be heated by this transistor. This is the heater element. It's a BJT tip 32, and it will heat all the surface here, and all the elements will be heated in the same temperature here. And so this is the oscillator. Let's see, we can see here the crystal. We have below the crystal temperature sensor, a thermistor that will sense the temperature, and in a closed loop we're gonna use this measure to close the temperature in a precise way. And this is the circuit I show in the part 2. See the part 2 if you did not have seen. This is the circuit of the oscillator, and now I'm working on the circuit of the heater. This will be the circuit, a very simple closed way first order loop here, and with a Darlington PNP pair here, chip 32, BC557 here, and BC557 here to control the maximum current that will flow in the heater to match the impedance with the supply to get a good power transfer to the PCB heater. And the thermistor is here, and I think this set point here will be a zener. I will not use this divider because with the divider you're gonna be fluctuating the set point with the supply. It is not very good. So let's see here. We have 10 meg on the output. These two supplies are supplying the heater that's turned off now. We're gonna turn on in a moment. And this supply here is supplying 50 volts to the oscillator. And here the voltage 0 volts now to the VCO varicap to control the frequency. So let's change the frequency set point here. I will increase the voltage on the varicap, and the set point needs to go down. Let's see. Let's increase the voltage. Sorry, the frequency needs to go up because the capacitance will be less with more voltage. So we can increase the frequency here. I have now 1 volt, and in small increments, this is 14 Hertz in a 10 meg signal. Very nice control of the frequency here. Very nice control. With only 1 volt, we can control 10 Hertz in the output frequency. Very nice. Let's now turn on the heater to see how the heater will change the output frequency of the oscillator. I will decrease the control voltage here. This will start to conduct current on the heater device. Now we are conducting current on the heater device, and we are hitting the PCB, and I think the frequency will go down with the heat. Let's see. Yeah, the PCB is heating and the frequency is going down. Very nice. This is so beautiful to watch here. So beautiful to watch. And let's turn up the control here. And I think now Yeah, the PCB is warm. Very nice, very nice. I will put the output of the oscillator on the scope so we can see how the controller will sync the frequency. Using the scope, we can clearly see how the circuit will work, and that generator is generating our blue trace here, the standard for this demonstration. And we can see that I can increase the control, the control voltage, and we can lock one signal to the other. Let's increase the voltage in 10 millivolt steps. Let's increase, and we can get the signals in lock. We are getting the signals in lock. The DSP on the FPGA is that gonna do this work here to lock the signals. You see? The FPGA will control this voltage very precisely, and we can also now increase the temperature to see the drift. Let's see the drifting. We can see that now we are hitting and the frequency goes the other direction. That's so nice. So guys, subscribe to the channel. I see you in the next video in part 4, where we're gonna assemble the oscillator in the closure, and we're gonna test the closed loop, and we're gonna use a GPAB interface to connect the frequency counter on the computer so we can measure the frequency drift and get a precise spec on this oscillator we are building. So see you in the next video.